Looking to get your hands on the latest generative AI models accelerated by Nvidia? Today, we're going to show you how easy it is to try out and deploy the latest AI models for high-performance GPU-accelerated inferencing, privately and securely on your own infrastructure using a single command. First, we can find out what models are available on the Nvidia API catalog at build.nvidia.com. There are several models available across a bunch of different domains, like Stable Diffusion and ESM Fold, but the one we'll be using today is Llama 3. We can quickly test out the model right here on our web browser and see how it performs. For example, let's try asking the model to write a limerick on GPU computing. And here's the resulting output. We can also test out the model programmatically with the hosted APIs by generating an API key and using the sample code snippets here. To deploy a NIM ourselves, we can move over to the Docker tab on this page. That'll give us the instructions for pulling the NIM container and running it in our own environment. Note that in order to download NIM, you'll need to sign up for an account. You can sign up with a business email for access to NIM through an Nvidia AI Enterprise license, or a personal email for free access to NIM through the Nvidia Developer Program. You can choose the best option for your needs. Let's go over to the command line and see what the deployment process looks like. The first thing we'll need to do is log into the Nvidia container registry. To do this, we'll need to have Docker Engine and the Docker command line tool pre-installed. We can type in docker login followed by nvcr.io for Nvidia Container Registry. For the username, we'll use $OAuth token, and for the password, we'll paste in the API key that we got from the API catalog webpage. Now we're authenticated with the container registry. Our next step will be to create an environment variable called ngc API key in our session that holds the same API key value. I've already done this, so I'll skip that step here. And then to get things running, we just need to input the single docker run command, which I can paste in here. This will pull the container image, download the necessary model weights, and deploy the NIM microservice that we can use as a local API endpoint. There's a couple of flags here that I think are useful to take a look at. The first is GPUs all. This is telling Docker to expose all of the GPUs to the running container. In the next one, we're letting Docker know to expose the API key environment variable that we set previously. Here, we're mounting this path to opt.nim.cache directory within the NIM container. This is where NIM will download and store the model weights so that they don't have to be re-downloaded on future deployments. Next, we're specifying that the NIM should run as our local user. Finally, here we're exposing the port 8000 from inside the container to the outside. That's the main port where we'll be sending all of our HTTP requests in order to interact with the running NIM. And the last bit here is the actual container image, the image path and the tag. Note here that when we deploy NIM, we include the name of the model in the image path itself. So in this case, we'll be deploying the Llama 3 8B model, and if we were going to deploy the Llama 3 70B model or any other model, it'd be a different image path. And we could scroll then to the end of this log here and see that this last message is telling us that our service is running on port 8000 and that it's ready to listen for requests. To confirm that the service is ready, I can move over to another terminal and send this health ready request with curl. And I see the response come back with the message that the service is ready. So now that the NIM is ready, let's try sending a request. I'll try asking for a limerick again by pasting in this command to my terminal. And we quickly get back a response with a lovely little poem, just like we saw on the web interface. And that's a wrap. We've deployed one of the latest community AI models for secure, high-performance inferencing on our own Nvidia accelerated infrastructure. Looking to run more NIM examples? Check out the Jupyter Notebook and resources in the description.